Okay, guys, welcome. Today we're going to talk about rational exponents and radicals. Okay, so to start off, we're going to talk about what we mean by a square root or a cube root or an nth root. Okay, so for example, let's start off with something like a squared is equal to 25, right? So if you're given that, you're looking for a number. So we need a number such that if you were to take that number and multiply it by itself, you would get 25, right? So what is that number, right? So of course we say that a is the square root of 25. And then of course, in this case, a would be 5. But in general, if you're looking for a number that's a squared is equal to b, we say that a is the square root of b, right? And we would sort of indicate it as a is equal to square root of b, right? Now you could just as easily, let me give myself a little more room, we could have just as easily said the same thing for a cube, right? If we have a to the third is equal to b, then we're looking for a number a that if we multiply it by itself 3 times gives us b, and we usually say that a is the cubed root of b. And of course, you can generalize this to any power that you want, and we say that a is the nth root of b, right? So that's sort of what we mean when we say like a square root or a cube root or something like that. Okay. Now, one thing that we can also do as well that I want to maybe comment on here is that we can use our exponent rules in sort of a clever way here, right? If I want a's exponent to be 1, then I could raise this to a 1 over n. Of course, then I'd have to do it on this side as well, right? And then on that left side right here, I could use my power to a power rule, and if I do n times 1 over n, I'm just going to get a to the first, or just a. And of course is equal to b to the 1 over n, right? But if a is b over 1 over is equal to b over 1 over n, but it's also equal to the nth root of b, then really b to the 1 over n must be the same thing as the nth root of b. And of course, that is true, right? So this gives us sort of a way to talk about fractional exponents, right? And we'll comment on this in a little bit more. Now, one thing that I do want to comment on as well is the idea of a principal nth root. Okay. Now, when you take the even root of a number, you have 2 possibilities, right? So if you look at 25, for example, you could say that a is 5 or a is negative 5, right? Both of those would be true. If you do 5 times 5, you get 25. If you do negative 5 times negative 5, you also get 25. So either of them would do. Now, in order to sort of avoid ambiguity, we usually are going to choose the positive version, and we call that the principal. In this case, square root. Right, and in general, of course, it'll be the principal nth root, right? So most of the time we do consider the positive one, but just keep in mind that there are both a positive and negative solution to the even root problems. All right, so let's do a couple of examples. So in part A, we have 144 to the 1/2, right? Or another way you can think of that is the square root of 144, right? Now you could put a 2 there, but if it's not there, we assume that we're looking at a square root. Now, what does this really mean? I know that you probably know the answer already, but let's think about what this actually means. We're looking for a number x such that if I multiply it by itself or if I square it, I'm going to get 144, right? And of course, you probably recognize, that this is 12. But the real reason because 12 works is because 12 times 12, or 12 squared, is 144, and that's why this works. Okay, let's look at part B. Part B, we have -8 to the 1/3. Or again, we want the cube root of -8. Or again, we want a number x such that if I raise it to the 3rd power, I get -8. Right? And of course, if you think about this, you'll find that this number is -2, right? And that's because -2 to the 3rd is -8. Now in part C, we have a little bit of a dilemma here because we have -25 to the 1/2 or square root of 25. Or we could say we're after a number that if this should be negative, square it, I get -25. And of course, this is a problem, right? Because if you multiply a number by itself, you're either doing positive times positive or negative times negative, right? In which either case, you're going to get a positive to come out. So no matter what, if you multiply a number by itself, you're getting a positive to come out. So this actually can't happen. If you take a number and multiply it by itself, you can't get -25. So this actually has no solution. And I should be careful here. I should say no real solution, right? And we'll take a look a little later about what we mean by no real solution. But for now, we're just going to leave it as that. Okay, now in part D, we have something similar, only now this time the negative is on the outside. So of course this is going to be okay, right? So now in this case, we're looking for negative times the 4th root of 1/16. And of course, we're looking for a number that if I multiply by itself 4 times and take the negative, I'm going to get -1/16. Right? And of course, what you can also do is think of this as -1 to the 1/4 over 16 to the 1/4, which is -4th root of 1 over 4th root of 16. Right? And without writing out everything again, you're looking for a number that if you multiply it by itself 4 times, you get 1. Well, that's just 1. And then the number in the bottom, a number I multiplied by itself 4 times and get 16, that's going to be 2. Right? So of course, this number is going to be a 1/2, and then we want the negative of it. Okay. So now we are able to talk about what we mean by any fractional exponent, right? So if we have something like b to the m over n, right, where m and n are both just numbers. So we have any fraction that you can think of. Now there's 2 ways that you can think about this. You can think of this as b to the 1 over n all raised to the m power, right, which is the same as the nth root of b all raised to the m power. Or you could even think of it as b to the m to the 1 over n. Or you could think of it as the nth root of b to the m. All right. Now, most of the time, we usually consider it in these forms, right? Because we think about like cube roots or square roots, and they're usually a bit easier to think of rather than your like half power or fifth power or whatever, right? And my recommendation is usually to stick to this form, right? And it's usually easier to stick with this form because it's easier to make a number smaller and then larger. Then larger afterwards, right? Because if you apply your order of operations on this thing, you're taking a nth root first, which is going to make the number smaller, and then raising that number to the m power, which is making it bigger. If you do this one, you're making the number bigger and then smaller, which is usually harder to do. Okay, but let's do a couple of examples of this. So in part A, we have -8 to the 4 over 3. right? So in our equivalent forms, we could either write this, I'll write it out both ways, just for clarity for this first example, and then we'll do the other ones, probably without writing both forms out. But in this case, the number on the bottom of the fraction is telling you the type of root, right? So this is a cube root of -8. And then the number on the top tells you the power that's coming out here. And again, we could also think of this as -8 to the 4th, and then take the third root of that. All right. But this -8 to the 4th is going to give you a big number, right? So this is usually harder. So let's do this form. Well, the cube root of -8 we just saw was -2. And if we raise that to the 4th power, we get 16. And we didn't have to work with any extremely large numbers there. So that's usually the way that we want to do this. Okay, in part B, we have x to the 1/2 times x to the 3/4. Right, so first we can apply our multiplication rule, so we need to add these exponents. Now, if we add these exponents, we need a common denominator. So this is x to the 2/4 plus 3/4, so x to the 5/4. And of course, this is the bottom number tells me take a 4th root of x and then raise that to the 5th power. And since we don't know what x is, that's the best we can do. Part C, we have x to the 3/4, and we're squaring that. So now here I need to use my multiplication rule. So this is 3/4 times 2. And in this case, the 2 and the 4 would cancel and just leave me with the 2 in the bottom. So this is x to the 3/2. So of course, the bottom number tells me it's a square root, the bottom number in the fraction, I mean. And of course, the number up top tells me raise this to the 3rd power. So I get the square root of x to the 3rd. Part D, we have a 3x to the 2/3, y to the -5/3, all raised to the 3rd. Well, since I have a product raised to a power here, I can say that this is 3 to the 3rd times x to the 2/3 to the 3rd times y to the -5/3 to the 3rd. And what's nice here is that here my 3's are just going to cancel. And 3 to the 3rd is 27, so I'm going to get 27 times x squared, y to the -5th. So now we just need to move the y to the 5th down to the bottom, so we can make that exponent positive. Okay, so that's that example. Okay, now I've already started really using this notation, but we can talk a little bit further about radicals, right? So if I have something like b to the 1/2, we saw that we can write that as a square root of b, right? And of course, if we have b to the 1/n, we can write that as the nth root of b, right? So that's what that's saying right here. Okay, now there are some restrictions that we have talked a little bit already about with some examples, and that's that if you're taking an even root and your number on the inside is negative, then the solution is not a real number, right? And we'll talk a little bit later about complex numbers, and we'll be able to say something a little bit more about that, all right? And then, of course, if your root is an even root and the number on the inside is greater than or equal to 0, then for this course, we're going to choose the non-negative number, right? So we're only going to take the positive or the non-negative number so that we sort of avoid some ambiguity. Okay, so now I just want to showcase sort of going back and forth between fractional exponent and radical form, and we'll simplify our answer and use only positive exponents. All right, so in part A, we have 2x to the -3/2. right? Well, the first thing that we'll do is let's go ahead and put this in the bottom so we don't have a negative exponent. Well, now we have a fractional positive exponent, so we can say that this is the square root of 2x all to the third power, right? And for now, we'll leave this alone as it is, but we'll see a little bit later on that we usually don't want to leave our solution having a radical in the denominator. All right, but for now, we'll leave that as is. Now in part B, we have the 7th root of y to the 4th in the bottom and 1 over that, right? So what we can do here is if we convert this to fractional form, the number on the inside tells me the number on top, and of course type of root tells me the number on the bottom. And of course we could say this is also y to the negative 4 over 7. But if we don't want negative exponents, we just want positive, then we can just leave it in the bottom still. Okay, part C, we have negative 3a to the 3 over 7. And if we wanted to write this in radical form, this is a 7th root of negative 3a all to the third. Right? And then in part D, we have square root of x squared plus y squared. And now we can just write that x squared plus y squared as a 1/2 power. All right, now be careful here. You don't want to say that this is equal to x squared to the 1/2 plus y squared to the 1/2, right? As soon as you have that plus in between here, you're kind of tied about simplifying it any further. So this is not true, all right? So just want to make sure that's clear. Okay. Now, one last example is that if you have something unfortunate that's like this, that you can't compute sort of by hand, you can use a calculator to do this. Now I want to show you what exactly goes in the calculator here. Now to put this in a calculator, you're going to type like sort of the caret button to get you into the exponent. And since you have a fractional exponent, you want the rest to be in parentheses. All right, so fractional exponent in parentheses. Right, and this is usually somewhat difficult if you're going to try and use a phone to calculate this. So I recommend using like a scientific calculator only to do this type of thing. So if I wanted to do 7.62 to the 3 over 4, you should get something about, and again, this is approximate, 4.58634. So. Okay, so that's maybe one thing that I would try on your own to make sure that you can sort of type that in the calculator correctly, which sounds silly at first, but you'll find that if you don't enter the parentheses for the exponent, that you will get something different. All right, so that concludes this video on rational exponents and radicals. I hope you enjoyed, and I will see you next time.